Alright, for today's lesson we're going to look at horizontal and vertical lines. So it's going to be in a continuation of the graphing that we've worked on. So there are some special cases that we can deal with that are horizontal and vertical. So remember that a linear equation can be written in this form, ax plus by equals c. So I can plug in values for x and y and they should add up together to give me a third point, or answer. So if either a or b are 0, so let's pretend a is 0, I would be left with this equation, by equals c. Or if I had b equals 0, I would have ax equals z, or c, because the 0 multiplying by 0 would take away this term. It's kind of like finding the intercepts. So it says if either a or b are 0, then either the line is parallel to the x-axis. So remember, here's your axes, x and y. Parallel to the x-axis means it would go this way. And if it was parallel to the y-axis, it would be vertical, going this way. So you could have horizontal lines or vertical lines. So let's look at some graphs and see the situations where this comes out to happen. For the graph line, complete the table of values for the points on the line. So looking at the points that are listed, starting over on the left, I've got -4, comma, 3. Another point that's highlighted for us is 0, comma, -3, or +3, sorry. 2, comma, 3. And then last that's listed is 5, comma, 3. So looking at this table, no matter what I put in for x, my outcome or my y value is 3. So this equation is y equals 3. Anytime you have a horizontal line, you just say whatever the y value is, and you say y equals that number. So it's a special case of an equation. The flip side is when you have a vertical line. Here, let's list our coordinates. So starting on the bottom and working our way up, I have -2, -5. That's this point right here. -2, -2. -2, 0. And then -2, and it looks like it's at 2.5. Just like above, no matter what values I put in for x, or whatever I put in for x is going to be the same each time. It's always -2. So my y values are changing, but my x values are staying the same. So in this one, I just say x equals -2. So anytime you have a vertical line up and down, you just say x equals whatever that value is. Let's look at one more example. Here I have a line. There aren't any points listed, but I can list some points pretty easily. Or if you think you can get to the equation already, try guessing the equation based on what number this is going through and the direction of the line. So looking at here, any point on this line I can list in the table. So I'm going to pick some points. I have -4, -4. -2, -4. 2, -4. 4, -4. So again, there's a pattern here. No matter what I do, my y values are equaling -4. And I can just look at the graph and see that. So the summary of what we've done is an equation of a vertical line looks like this. Anytime we have a vertical line, let's look back to our example on the front. That's a vertical line. So whatever the value is, we just say x equals that point that it's going through on the x-axis. So it's x equals some number, and I'll just say a. And it looks like that. A horizontal line is when it's going parallel to the x-axis. And that's when your graphs are horizontal, so that was like number 1 on the front. And here, it was just a line going through the y value, so y equals 3. So I'll just say y equals some number. And that's it. Try finding the equations of the lines on the next page, and that'll be it for today.